Good evening everyone. Welcome to my class. Almost after 1 week I am taking the class. Okay, that's why if possible I will take the class every day. Maybe today they are telling they will not take any general classes. We will see that one later. Good evening everyone. Can you hear me? Yes. Welcome to my class. This is not the optics first class. Already reflection, refraction, everything I completed in optics. Then we will discuss few MCQ questions based on the topic what we discussed up to here. Once again, good evening everyone. Shall I start the class? I will take only 1 hour, 4 to 5 o'clock. I will discuss few MCQ questions based on optics, what reflection, refraction, what we studied. Then this one already I explained in the case of a plane mirror. Can you hear me? Tell me, anyone, if you are able to hear properly. Can you able to hear? I am not using headphone, that's why I am asking. Yes, you can hear me now. Light start from a source and bounce of object, surface of another medium, properties of image in a plane mirror. This one we know. Can I make a call? Because my father is not well. That's why my mother is calling. Any emergency, I will call. You solve this question. I will be on the line only. Hello? Class sorry, because my father is not well, no, that's why some emergency call it will come. Okay, can you solve this? Yes, once again I will explain this one, then we will solve MCQ questions. Okay, oh here I don't know why little changes happened here. Okay, let it be. Yes, light start from a source and a bounce of object, surface of another medium. Here the property of image in a plane mirror is always, you know, that plane mirror you will get which type of image you will get, virtual and erect image. Then the size of the image is same as that of the size of the object. This also you have to remember. Then in the case of a plane mirror, the image formed is as far behind the mirror as the object is in front of it. The image is laterally inverted. These are the few points already I explained. Once again I am revising the properties of a plane mirror. Then here this I'm not included in the last class. We had a confusion what is the formula we will use to find the number of images. This is the formula, number of images. To find the number of images in a plane mirror, we will use this formula, 360 divided by theta minus 1. Then in the case of a plane mirror, already I told virtual image we will get. Virtual image means when you extend the reflected rays, it will meet at a single point. That rays are imaginary rays. Imaginary, they are meeting. Okay. Therefore, the image formed by a plane mirror is virtual. Then here, this one we will call it as a erect image. Erect image means here left, right, both they will become ulta. Yes, no. In this case, left side it will become in the mirror. It will be the right side. That one we will consider as a erect image. Then let us solve few MCQ problems based on this one. The angle of incident of a ray falling on a plane mirror is 45 degree. Then the deviation produced by the plane mirror. If you know the formula, calculate what is mean by deviation. Angle of deviation, we can listen here. This one we will consider the angle of deviation. This one, okay. This is the normal. This is the normal for a particular mirror or particular plane. Then here, after hitting this mirror, consider this is the mirror. Okay, this is the mirror, this is the normal. After hitting the mirror, then see, it will get reflected in this direction. Angle of incidence, it will be equal to angle of reflection, you know, according to the first law of reflection. Then here, angle of deviation, that we will indicate it by delta, that it will be 180 degree minus 2 theta. This formula also we will use. One more formula I will write, both also same. 180 degree minus angle of reflection plus angle of incidence. Both also same, no? That's why directly you can use in this formula, because in the case of a plane mirror, okay, angle of incidence is always equal to angle of reflection. Then if I consider this one as theta, then theta it will be equal to theta. This one you can directly you can use this formula. This here minus 2 theta is nothing but these two, if you add, you will get 2 times. Okay. Otherwise you can use this one also. Both the formula we will use. Better use the first one only. Here 180 degree minus 2 theta. Then here how much they are given theta value. The angle of incident of a ray falling on a plane mirror, theta is 180 degree, 45 degree. Then 180 degree minus 90 degree. This value it will be 90. Okay, this one we will. Rakesh, yes, good evening everyone. Then here the angle of incident, otherwise angle of incident of a ray of falling on a plane mirror, that is 45 degree they are given. Then they are telling to calculate the angle of deviation. We will use this formula. With the help of this formula, already they are given the theta, then you substitute, you will get the value. Here 90 degree, option 2 is the correct answer. Okay, easy, you have to remember the formula, angle of deviation formula, then substitute, you will get the answer. Then here second question, solve, but here they are given one condition. Try to solve. The ray of light reflected at an angle 15 degree. If the angle of incidence is doubled, then the angle of reflection. A ray of light is reflected at an angle of 15 degree. If the angle of incidence double, then the angle of reflection will be. What is the meaning? What is the meaning of this one? Then what is the angle? Calculate. Here they are given the condition. Here they are given a ray of light is reflected at an angle. Okay, incident, reflection. In the case of plane mirror, you know, angle of incidence, it will be equal to angle of reflection. Here they are given angle of incidence, that it will be angle of incident double. In place of I, consider 2I, because they are given the condition, it is double. Then angle of reflection, you know, it will be equal to angle of incidence. Then in place of angle of incidence, write two types of angle. Okay, this it will be in terms of angle. Then 2 into what is the angle they are given, 15. Then angle of reflection, it will be 30 degree. Your answer for this question is option C, 30 degree. Are you following, everyone? Are you following? Here they are not asking angle of deviation. Here they are asking, you have to remember, in the case of a reflection, two laws are there, no? Reflected ray, incident ray, then normal. All the three, they will be lie on the same plane. That is second law. First law, angle of reflection, it will be equal to angle of incidence. Okay. Then here they are given, condition they are given, if the angle of incidence is double, substitute, you will get the value. Easy question. Maybe here they are asking double, sometime they will ask different. This also already I completed, but I will do a quick revision because so many days over, no, almost like 1 week. Everyone, you forgot the concept. In the case of a concave mirror, when the object, and also for revision wise, it will be easy. Which type of mirror, which type of image it will form in plane mirror, concave mirror, convex also. Everything I made like a slide I am explaining. For revision, it will be easy for you. Next one, in the case of a concave mirror, when the object is at infinity, but the rays coming from it are parallel to the principal axis. See, when the object, when they will be at infinity, we don't know that object, then, but we will consider always the two parallel rays, that two rays, they will be parallel to this principal axis. This is the principal axis. Then after reflecting the mirror, what they will get? Converge in a single point. When it is converging, even anything is converging in a single point, that one we will consider as a real image. When two rays, not anything, when two rays after reflecting, they will meet at a single point, then that point we will consider as a converging. Then in that case we will get a real image. Then here, in the case of a concave mirror, the image is inverted. Inverted means ulta we will get. The image is diminished. Yes, no, you can compare the size of the object to the size of the image. Almost it will be diminished. Then next one, the image formed is at principal focus. This is the focus. The image always it will be formed at principal focus. Then where we will use this type of mirror, concave mirror, we will use torches, searchlights, vehicles, headlights. Already I explained this one in detail. I will go fast. To get powerful parallel beam of light, we will use a concave mirror. Next we will move to the next one, convex mirror. Are you following? Because this one already I explained when I am explaining reflection, refraction, spherical mirror, everything is finished. Then today maybe 2 classes I will discuss only MCQ question based on the topics. Then after we will see the remaining next topic I will move. This is like a revision class for you, this one. The next one, convex mirror. When the object is at infinity, the image is virtual. When you will get the image virtual means when you extend the reflecting rays to a single point, okay, all the rays they will appear to meet, but exactly they are not meeting at a single point. That type of image we will consider as a virtual image. That one we will call it as a diverging. Converging means we will get a real image. Diverging means we will get a virtual image. Erect means always right, left, both they will get exchange. That we will consider as a erect image. Next one, the image is diminished at a point. In case of a convex mirror also, always you will get a diminished mirror at a point. This one I am talking only about the when you place the mirror at infinity, not for all the cases. Okay, only when you place the object at infinity, that one you have to remember. Then the image is formed at principal focus behind the convex mirror. Where you are getting the image here, you are getting the image here. This is the mirror. This is the front side of the mirror. Correct now? Here, this is the mirror. This is the reflecting surface. Otherwise, I will write here. This is the reflecting surface, is nothing but the surface of the mirror. Then here, which is the position of the image? The image, it will form behind the mirror. Correct now? This is only applicable if you place the object at infinity, because at infinity point, that is very, very important. It has so many applications. That's why I am telling this one. Okay. Then image is formed at principal focus behind the convex mirror. Remember that one. Then where we will use this convex mirror? In a rear view wing mirror, because they always give an erect. Through diminished image also, they have a wider field of view, enable the driver to view much larger area. We will use this in mirror vehicles mirror. We will use the convex mirror. Okay, why we will use means, this is the reason we will use the convex mirror in the vehicle, because you will get a virtual image, erect image you will get, and the image is diminished, because even though big object is behind you also, it will diverge at a single point. Otherwise, the diminished image you will get on the mirror. Okay. Next, this also very, very important one, what I am explaining now, because everything we will include when it will help when I will solve the MCQ problems. Okay, even today, I'm sorry, my energy is low, because yesterday I came, because I don't want to waste even 1 hour also. That's why immediately I took the class without taking the rest. That's why even my energy is low. Even my mind also little, it will be blank. In your family also you will feel like that only. Any close one, like parents, if they are not well, then our mind also little, it will be like, we will be worried. Aged person means we will be worried. Correct no? That's why. If you are not able to follow anything, please ask me. If you have the doubt, ask me. Next, sign convention for a reflection by spherical mirror. This one you have to remember in the case of a spherical mirror. This is already you know in the maths, first quadrant, second quadrant, third quadrant, fourth quadrant. This is the x-axis, this is the y-axis. Then here first quadrant, what is mean by that? X and y values both also positive. In second, x is negative, y values are positive. Then in third quadrant, both the values are negative. In fourth, x is positive, y is negative. Because why I am writing this one, if you know this one, then no need to, you will not get confused. We will use different sign for focal length, in which case is positive, negative. Then when we will solve the problem, we will use this one. That's why better you remember this one, it will help for you. Next one, sign convention for reflection by spherical mirror. Then here, first point I will explain here, the pole P, that is nothing but origin. Here, this is the pole in the spherical mirror. In the quadrant, this 0. Otherwise, this point we will consider as a origin. The principal axis, x-axis of the coordinate system. This is the principal axis, correct no? x dash, this one x dash, this is the principal axis. Then here which one is the principal axis in the coordinate? Then x axis is the principal axis. Then first point, the object is always placed to the left of the mirror. Always, this one is very important. Where we will place the object? Always left of the mirror. This is the mirror. Left side of the mirror we will place the object. Object on the left. You can always remember, if not only the spherical mirror, in the plane mirror also, object we will placed at the left side of the mirror. Object is always placed to the left of the mirror. The light falls on the mirror from the left hand side. Then light, it will fall from this side only, left side only. It will hit the mirror, then it will get reflected, even refracted. That it will be different case, but that point also you have to remember. Are you following? If you have the doubt, ask me. Next one, all distance parallel to the principal axis are measured from pole to the mirror. Always from pole, from here we will measure the distance. Because consider here, if the object, if the image is formed in front of the mirror only, I will write somewhere here. Then calculate this is the image. Okay. Then calculate the distance of an image from the mirror if they ask in the exam. Then from the pole we will measure the distance between the image and the mirror. From the pole we will take. Okay. Not from here, not from focus, not from the center of curvature. No. From the pole we will measure the distance of a image. That one is very important. You have to remember. Then next point, all the distance measured to the right of the origin is positive, left of the origin is negative. Okay. Then here, all the distance measured to the right of the origin. Okay. This is the origin consider. Then this is the right of the origin means what? X axis always we will consider as a positive. Here also in the same way, in the spherical mirror, this is the right side. If you measure the object distance or image, object distance, it will not come because you are placing the object at the left side. But here consider, if you want to calculate the position of an image, otherwise the distance between the image from the spherical mirror, assume you will get like 10 meter. Then here if you get an image, okay, at the right side of the mirror, then this value we will consider as a positive. 10 plus 10 meter plus 10 meter. Always we will consider distance towards the right is positive. Then distance towards the left, that it will be negative. Consider this is 20 meter. Then in this case the image distance from the spherical mirror, it will be minus 20 meter. Are you following? This one you have to remember when you are calculating the numerical problems. This one is very important. Okay. Otherwise you will get confused. That is very important thing. Then next one, the distance measured perpendicular to above and below the principal axis along the y-axis, that is positive. Next one, distance measured perpendicular to or below the principal axis along y-axis is negative. Better don't remember these two. Better remember with the help of the diagram. It will be easy for you. Here listen how we will consider the height of an image. Here this is the principal axis. Consider this is the principal axis. Then if the image is above the principal axis, then height, it will be upward. Height we will consider as a positive. Then next one, next case you can remember here, this is the position of an image. Then here the height towards negative, because this image, otherwise this one is the inverted image. Consider because A dash B dash, normally we will get in the case of a inverted only, ulta image. Okay, in that case the height of the image we will consider as a negative, because here this is the principal axis Above the principal axis, the height of the image we will consider as a positive. Below the principal axis, we will consider the right of the image, it will be negative. Okay, then we will move to the next one. Okay, up to here understood? Ambika, I will answer you at the end. Okay, because my concentration it will become miss. I will, don't worry, I will tell at the end. This is the principal axis. Above the principal axis, the image the height of the image is positive. Below the principal axis, the height of the image is negative. Then one more important thing, this one, can you hear? Sorry, can you see? Otherwise I will make little enlarge. Listen, this is the case of a concave mirror. This one in the case of a convex mirror. Here already you know this one. In the case of a concave mirror, the reflecting rays, they will meet at a single point. That one we will consider as a converging. In that case, focal length always we will consider as a negative. This also very, very important. What I am explaining now, I am explaining slowly, because this definitely they will ask in MCQ, and also when you are solving the problem, focal length in which case we will consider as a positive, which case we will consider as a negative. That also very, very important. Yes, Suma Devi, good evening. Okay, next one, in the case of a convex mirror, here you can see the convex mirror, the rays they will get diverge. Okay, then they will meet at a single point. In that case, the focal length it will be positive. What is mean by focal length? The distance between the pole and principal focus, F. The distance between the pole and the principal focus, that distance we will call it as a focal length. Those who don't know, those who are not able to remember, better you revise one more time. My class, what I am explaining, everything in detail I explained. Next important thing I will move. Mirror formula and also magnification. Up to here everyone you understood? No doubt, no? You don't have any doubt? Remember this one, it will be easy for you. Remember, otherwise you can correlate this one with your coordination system. Otherwise, if you are able to remember easily, means you can remember also. Next one, mirror formula and also magnification. When we will use the word magnification, magnification is nothing but enlarged. When we will get the enlarged image, magnification is nothing but enlarged image. When we will get the enlarged image, then we will get the magnification, means the size of the object is small. Then using the magnification you will get the bigger image. That one we will call it as a magnification. What is mean by U? The distance of the object from its pole. Already I told, always whether the distance of the object, otherwise the distance of the image, always we will measure from the pole. Here consider the distance of the image from the pole of the mirror. Next one, the distance of the principal focus from the pole. Yes, Samika, for convex lens magnification it will happen. Okay, enlarged image you will get. Then we will use this formula to find out the magnification. 1 by V plus 1 by U, it will be 1 by F. F means the focal length. Then what is the formula we will use to calculate the magnification? Magnification is nothing but M, it will be equal to height of the image is nothing but H dash divided by height of the object. Height of the image divided by height of the object. Always remember, it is nothing but magnification. Then magnification is nothing but it is indicated by small m. It will be equal to H dash divided by H. H dash means height of the image divided by height of the object. This it will be equal to minus v divided by u. Next one, okay, magnification, it is indicated by small m. This value is h dash divided by h. It will be equal to minus v by u. This v by u sometimes we will consider positive, sometimes we will consider negative. Let us see. The height of the image should be taken as positive for virtual image. Wherever you will get a virtual image, in that case we will consider the height of, see, the height of the image should be taken as positive in the case of a virtual image. Then we will consider negative in the case of a real image. Then here negative value, it will indicate whatever the image you will get is a real. The negative sign in the value of the magnification, it will help the image is real. Negative sign of an magnification, it will indicate the image is real. Then positive sign in the value of the magnification, it will indicate the image is virtual. Virtual means you are not getting exactly on the screen. Real image means the image you will get exactly on the screen. That is the meaning of real and virtual. Even one more, every time I will tell how you will get a real image by converging this one with the help of diverging rays. Converging rays and also this one with the help of the diverging rays. That also every time why I am repeating means you have to remember. Up to here understood? In which case we will use the magnification minus sign. In which case we will use magnification positive sign. Negative sign in the case of a real image, positive sign in the case of a virtual image. Very important concept what I am explaining today. Definitely MCQ questions they will ask based on this topic only. Based on this, it will be very important. This one I included the answer. Don't worry. Okay, no problem. I will explain. A girl stand at a distance 30 centimeter from the mirror. Okay. They are given the object distance, that is 30 centimeter from the mirror. She is able to see her erect image. Erect image means left side it will become ulta, right left. But 1/5 height of the actual height the mirror will be. Which type of the mirror we will use here? Erect image, but 1/5 height of the actual image. Here whatever the image you are getting here, that is diminished, correct? No, that is the meaning. Actual image, if it is 100 by 5 means how much you will get? 20. Then here you are getting a diminished image. I am telling one example to understand. Okay. Then a girl is standing, that is 30 centimeter from the mirror means this is the object distance. Then you will get a erect image. That image it will be diminished. Here they are not use the word diminished, but here when you are reading the question only you have to understand, because the height of the image is reduced. What is mean by that? Height of the image is reduced is nothing but the diminished image. Then here which type of mirror we will use to get the diminished image. We will use the mirror, convex mirror. Here I included small and erect image is formed only by convex mirror. Plane mirror form image equal to the object, but concave mirror form image bigger than the object. Very important. That's why I included these 3 points. Always you have to remember. In the case of a plane mirror, you have to fix in your mind the height of the image, it will be equal to height of the object, it will be equal to height of the image. Both image height, both, otherwise height we can call even size also, we can call height. Normally we will use the word height in the case of a mirrors, or spherical mirrors, even lens also we will use. Okay, plane mirror form image equal to object height. Better here I will include the word height. Here nothing we mentioned here. Small and erect image is formed only by convex mirror. Plane mirror form an equal image equal to object, but concave mirror, which type of image you will get? Image bigger than the object. Bigger means you can use the word even enlarged also. Okay. Using this concept, they may ask 3 or 4 questions. Okay. Remember, convex mirror, which type of image you will get? Small and erect. Okay. Plane mirror, same size. Otherwise, plane mirror form images equal to the object. Otherwise, same height also we can consider. In the concave mirror, the image you will get that it will be bigger than the object, that is enlarged. Understood everyone? Then try to solve the problem. Tell me 16th one, the correct expression which indicate the relation between focal length, image distance, object distance for spherical mirror. Now only I explained which is the correct formula. Tell me A, B, C, D. Mention A, B, C, D. That is enough. Yes, tell me. Now only I told the formula. Tell me which formula is the correct. Out of A, B, C, D, which one is correct? Answer me fast. Uma Devi is telling A. Remaining? Only one is answering. What about others? Okay, option 1 is the correct answer. The correct expression which indicate the relation between focal length, image distance and object distance of a spherical mirror. I will move to the next one. If the distance of object from concave mirror is 4 times the focal length, then the position of the image will be obtained at. I have to leave the space, but I forgot to leave the space. Okay, leave. I will write here only. In the case of a concave mirror, always remember, in the case of a concave mirror, focal length is negative. Already I told focal length is negative in the case of a concave mirror. Then here they are given if the distance of object is u from the mirror is 4 times the focal length. U is minus 4 times of f. Here y minus sign means here the concave mirror we are using. Always remember, in the case of a concave mirror, focal length is negative. But here they are given the condition if the distance of object from the concave mirror 4 times the focal length, 4 times of f. Okay, 4 times of f, then the position of the image will be obtained at. What is the position of the image? They are asking V. Calculate. Already U I told, F. U I given, V is given. Do it. Substitute. You know the formula. Substitute. You will get the answer. You know the formula. 1 by F. It will be equal to 1 by U plus 1 by V. Write 1 by F as it is because they not told anything about the focal length. Then here, otherwise what I have to calculate, I will write here. Okay, leave. Then here, what is the value of minus, what is the value of U here? The U value is minus 4f. Substitute here minus 4f plus 1 by v. Okay, then 1 by f, I will shift this one here, plus 1 by 4f, it will be equal to 1 by v. Then take the LCM here. One by f, oh, in the case of this also minus only. This also minus, because focal length everywhere in the case of a concave mirror it will be minus only. Take the LCM here, minus 4f plus f divided by 4f, it will be 1 by v. I will write in the next, okay. I have to leave the space, but I forgot to leave here. C is the correct answer, Amrika. Very good. C is the correct answer. Simplify here, minus 3f by 4f, it will be 1 by v. F, it will get cancelled. V, take the reciprocal, you will get 4 by 3. Oh, here LCM is f square, no. F into f square. Then 1f it will get cancelled. Remaining one more f it will be there. Minus 4 by 3, minus 4f divided by 3. That is the correct answer. Uma Devi, yes, I checked. I am busy. I told no. I went to Mysore. My father is not well. That's why I am not able to reply. I will see. Whenever I will free, I will send. Don't worry. Understood everyone here? Here they are given in the question, if the distance of object from a concave mirror is 4 times of the focal length. When you are start reading the question only, you have to write q, it will be 4f. Then you are talking about the concave mirror, means always focal length is minus. Then here they are asking the value of v. Substitute here. Wherever you will get focal length, it will be negative in the case of a concave mirror. We will move to the next one. Understood now everyone? Definitely like this problem they will give. That's why today class I am explaining slowly. We will solve only few problems only. But you have to revise, you have to practice, otherwise in the exam, if you do little mistake also, it will become wrong. Next one, 18th one, the focal length of a convex mirror. Okay, here the focal length in the case of a concave mirror is negative. The focal length in the case of a convex mirror, that is positive. Always remember, focal length in the case of a concave mirror is negative. Focal length in the case of a convex mirror is positive. That is its value is given, that is 20 centimeter. Therefore f it will be plus 20 centimeter, producing an image at a distance of 10 centimeter from the pole behind the mirror. Here they are given the condition 10 centimeter behind the mirror. Then what is the object distance they are asking here? V is equal to 10 centimeter. Behind the mirror is positive. Here consider, if this is the mirror, here you are getting the image. Okay, this is the mirror. Okay, behind the mirror, consider if this is a mirror, behind the mirror you are getting means this is positive. In front of the mirror means the V value, it will be negative. Always remember this one. Then here if V you know, then calculate the value of U. Do it. This question is very easy. Do it. Always remember, the focal length in the case of a convex mirror is positive. In the case of a concave mirror is negative. Then one more thing, if an object formed behind the mirror, this is the mirror, behind the mirror is positive, in front of the mirror is negative, above the principal axis that is positive, below the principal axis it is negative. Okay, solve this problem. Once again I will meet you at 5:30. Okay, one more class I will take at 5:30 to 10:30, sorry, 5:30 to 6:30 I will take one more class. Okay, solve this problem. 18th I will discuss you at 5:30. One more, and usual your regular aptitude class, it will be there at 6:30. Okay, bye everyone. Solve this problem.